Hi, everyone. I am Brenda Kraus. So my first, already know what you want to do. Do you have an idea what your career is? Kind of maybe the general area that you're interested in. We're going to send out that poll. And I would love if you guys could respond to me so at least I feel like there are people on the other end talking. And I'll review those in just a minute. So let me go to the presentation. And first of all, the career path. We all start where we are right now, point A, and we need to get to point B, which is us in a career. And for some people, it's a straight line like this. They know what they're doing, they're totally on top of it, and it's a clear path. But that's the way it is for some people. For other people, it might look more like this, where it's sort of up in the air. And let's see. Looks like I'm looking at the poll questions up there in progress. The answers, I don't know if you guys can see them, but I'll tell them to you. Yes, I know exactly what I want to do. 19% of you do. Sort of, I know some areas I'm interested in studying, 76%, and no, I have no idea and want to keep all my options open. So I think that actually describes a lot of us, and I'll probably be talking to you sort of people, the ones in the middle, because that's exactly where I was. I had a point A. I kind of knew maybe where I wanted to go, but I wasn't quite sure. So maybe this presentation will help you and at least give you some support to know you're not the only one out there not knowing what to do. So in high school, I grew up in Pennsylvania, and it's a small town called Ephrata, Pennsylvania. And that's a picture of my hometown, Main Street up on top there. In college, in high school, I knew I wanted to go to college. My parents, neither of them went to college. My mom actually didn't even finish high school because she had to quit to work on a farm. And my dad did finish high school, but did not go any further. And so because of their example, I thought, you know what, I think it might be better for me to try and get a career rather than just a job. My dad was a mechanic and my mother worked at a fast food restaurant. Down in the bottom picture is Ephrata Senior High School, where I went to school. So knowing that I wanted to go to college, I did everything I could. I got the math classes I needed to take, the science classes, the English classes. I took AP classes. But my problem was I didn't know what I wanted to major in. I was toying between two different areas, computer science and chemistry. I liked computer science because it had programming, and when you wrote the program correctly and hit execute, it worked. And it's rather rewarding to get something that actually works. Chemistry, I had an amazing chemistry teacher. He was so excited about the subject, and when you walk into his classroom, he just made you feel like it was the most important subject. And for some reason, chemistry kind of worked for me. So knowing that I wanted to go to college, I ended up choosing a school in Pennsylvania called Susquehanna University. It's a really small school, about 1,400 people total, not in a class, but total that attended there. And my class was about a little over 350 students in my freshman class. I was accepted into the honors program there. And because I didn't know exactly what I wanted to do, but I knew it was in the science field, I was accepted as a science undecided major. It's kind of nice if you know the area, then you can at least apply into that group. By my sophomore year, I ended up choosing chemistry, and they had given me chemistry classes my freshman year and my sophomore year because chemistry in the sciences is the foundation anyway. You need chemistry for pretty much any of the sciences. And so I took that, and by my sophomore year, I chose that. And I also had a history minor thanks to some of the honors program classes that counted towards history. I ended up getting a minor just for fun. I don't know why. I also was involved in clubs, and to branch out from where I was in high school, which was rather shy, I was shy and kind of timid. I decided to become a cheerleader, but I had the most fun my sophomore through senior year as a mascot. Really fun. So I have, Kathy, if you could do the next poll question. For me, I didn't know what I was going to do after I graduated. That was the issue I had. and I graduated with a chemistry degree, but I didn't know what I wanted to do. What jobs are out there for a chemist? What does a chemistry job look like? I really had no idea. So I'll let you guys answer, but in the meantime, the perceptions of a chemist. So my problem was, in high school, I was shy, but in college, I became more outgoing and realized that I liked being around a lot of people. I joined my college sorority, and I realized that I wanted to be around people, but I was afraid that I wouldn't be around a lot of people in the lab. And so let's see, I think we'll try and stop the polling. Thank you for answering. The question is, what does a chemist job look like? A person wearing safety glasses, gloves, and lab coat, working in a laboratory with many people, or working alone. So the first one was 63%, 15% is if you thought you were gonna be working alone. 3% say you're gonna be sitting at a desk, computer all day, and 19% say you're gonna be meeting with people in different labs and offices. So for me, I actually thought only 15% of you had the perception I did, and that was, I thought that I was gonna be alone in a lab. I thought that it was just gonna be a really isolated thing. In fact, my perception is that I would be something like this guy. I don't know if you guys recognize him. My kids always watched Professor Doofenshmirtz from Phineas and Ferb. And these, sometimes scientists are viewed sort of as mad, private, alone people. I didn't have him as a role model, or not that he's really a role model, but as somebody to think about as a scientist. I actually had Professor Honeyduke, the guy on the right, and his lab assistant Beaker. They were my, what I thought of when I thought of chemists. And Honeyduke was the mad scientist, and Beaker was always getting blown up. And so I was afraid that I was gonna be stuck in a small lab. And I didn't want to do that. I wanted to be around a lot of people. And so I decided to take 1 year off. And when I graduated from college, I had the opportunity to work for my college sorority. So it was a great position. I worked for my sorority and I traveled around the United States. And I was put at a bunch of different universities, and I helped with member recruitment, officer training, academic assistance. And I did that at schools in all of these different states that I just highlighted in red with red stars. And then the last place that I was put at as part of this 1 year job was starting a new chapter. And that was in the eastern side of Idaho in a place called Pocatello. And this year was great for me because I got to see a lot of the country. I got to become more confident in myself. And I realized when I was done, I'm ready. I am going to go become a chemist because that's what and you know what, I can do it. I can take whatever job is out there and I can make the best of it. So I started my job search. Well, now I've been around the US and I'm confident that I can go anywhere. So I sent out over 100 resumes all over the United States. This was before the internet. I couldn't just apply online. I did networking with people that I knew that were involved in science jobs and tried to get a potential lead that way. And then because I had been in Idaho for a while setting up that sorority, I knew of some companies there, and one was called Simplot Foods, and they hired chemists to help in their food industry. And so I had to apply through an Idaho job service, and that company represented many companies in Idaho, but specifically Simplot Foods, which is why I went there. So out of the blue, a company that I did not apply to and did not know anything about calls me, Micron Technology. I didn't even know what they were. I had to look them up. I talked to people and said, what is this company? And people who had been to Boise, Idaho told me what it was about. It's this chip manufacturing, memory chip manufacturing. I didn't know anything about that, nothing. I knew chemistry and that was about it. So I find out that there's a PhD chemist. He's looking to hire someone with a bachelor's degree in chemistry for a synthesis chemistry position in Boise, Idaho. I went over and I interviewed, and I was going to be working in a lab with one other person. And I thought, oh, that sounds horrible. That's not what I wanted. I wanted to be around a lot of people. But I kept my mind open and I thought, you know what? You just got to get a job, make some money, maybe get some things in line, and you know, you'll see where the job takes you. So I accepted. So what is my job? Well, I started in Pennsylvania and ended up in Boise, Idaho. And my job was a synthesis chemist, first and foremost. I did hands-on laboratory work. So we would take chemicals like the one you see on the left, we call it TICL, TiCl4, and it's titanium tetrachloride. We would react it with other materials, such as this lithium dimethylamine, and you would have a reaction where you would then replace these chlorines with these dimethylamine ligands. So anything that's attached to this metal center, we call these ligands. And here's the reaction up above for those who are interested in chemistry. That's the balanced reaction. And this is a precursor that we used to deposit titanium onto the wafer. It's called tetrakis dimethylamino-titanium, but we called it TDMAT because that's way shorter. So my job was to come up with new materials like this one and try to find materials that would easily deposit titanium on the wafers that Micron Technology used to move electrons around and conduct electricity. So the chemical on the right is bis 2,4-dimethyl-1,3-pentadienyl titanium. And that was the first one that I came up with shortly after I got hired on. I did not come up with the chemical itself. I came up with using this chemical as a source of titanium and titanium nitride on the wafer. And I actually got my very first patent on this chemical and the use of it to deposit titanium. So I did this synthesis work, and it was very exciting, very hands-on, very fun. But once I did the synthesis work, I needed to figure out if these materials actually worked. So I had a great job because I got to do some engineering work as well. The picture on the right is a picture of a deposition chamber that we built in my department, in my group. And the schematic on the left is basically a schematic of what that red and white section is, which is the process chamber. Titanium is very oxygen reactive, and so we needed to keep everything in vacuum so it wouldn't react with the oxygen. And we would bring in the titanium, the TDMAT, through a gas line. That's what these are here, these gas lines. And you would have reaction gases like ammonia, and they'd come in some of these other lines. We'd heat up this TDMAT, make it into a vapor. Basically, think about water boiling and it comes off as steam. Well, we'd heat up this TDMAT and we'd get it into a vapor form and we'd bring it in. It would distribute over a wafer through this shower head. Here's our silicon wafer. It's the orange one at the bottom here, and it's heated up. And what you would have is the reaction at the bottom, where you would take this TDMAT and you'd react it with ammonia, and you would deposit this titanium nitride on the wafer. And then you'd get other byproducts that you see on the right. The purpose was to deposit the titanium nitride because it conducts electricity, and it's a way for us to move the electrons to store our charges for our memory cells. So this job that I thought was going to be really isolated ended up being very exciting. There was a ton of human interaction. What I liked best about my job was the synthesis part, where it was hands-on, and I got to discuss about chemistry with supervisors and colleagues. And also there was a group of analytical chemists who I would give my synthesis product to, and they would tell me whether it was the correct product or if I had messed up my synthesis, and then I had to revamp that. In the CVD engineering job, I worked with a lot of different people to build that equipment that you saw on the prior page. And I also worked with surface lab scientists in film analysis. So once you deposit that titanium nitride, you have to figure out, is it pure titanium nitride? Is there carbon in there, which is going to change the electrical properties? Because you have an oxygen leak, and so that totally would mess up the film. So there was a lot of interaction with that. Once I got the film that I needed, then I would work with the process integration team. And this is the team that was involved in testing this on memory products. So it was very nice and very interactive with all these different groups. And finally, there's obviously manager interaction, where you have to report your findings to not only your supervisor, but other managers about that are helping to support the programs for the memory that you're looking at. So my career now is I've actually gone away from the synthesis part. I have to admit, I do miss it at times, especially the hands-on, and when I'm here at home, not in a laboratory, I'm kind of sad about it. But my new job is amazing. I'm a principal engineer in the thin films department, and I develop new film processes for both traditional like DRAM, NAND, memory systems, and then also some new ones like some emerging memory systems that we're working on for the future. In my job, I had the opportunity to spend 3 weeks in Japan. I was there to transfer an R&D process, and the pictures that you see are me visiting some of the sites. Well, that's not me on the right hand. Those are just some girls that we met in traditional Japanese clothing, and they were so nice and let us take their picture. I also have 46 issued patents on the chemistries and processes that I've worked on. I have some international patents and some other ones that we're still applying for, and I'm a huge, huge proponent of STEM careers. I only have a bachelor's degree in chemistry, but the bachelor's I think is the start. I think it's a great way to get into chemistry and the STEM careers. In fact, as a chemist, I'd like to use the periodic table to tell you why I think STEM careers are exciting. In this slide, you can see the periodic table. It doesn't have all the elements, not all the new ones, but back in the 1980s, the ones that are highlighted in blue were the only ones that were used to make any kind of memory chip. In the 1990s, this is when I got hired on, you can see that we branched out to some materials that are here in the transition metal area, and titanium. That's why I got hired on, was to do titanium synthesis and deposition. You can see that was one of the new materials that they were looking at because it was more conductive than the other materials that they were using. This bromine over here, they ended up adding that as an etch gas to help remove films on the wafer. In the 2000s and beyond, you can see by the orange elements that have been highlighted that there are a ton of elements that are now used for memory chip fabrication. And why I like to show this is, to me, this shows why STEM is so exciting. If you look at what was around in the 1980s and 1990s, it's not very much, but you look at what you're starting to use, what elements you're trying to look at, what research you're doing, and you can see that it is so broad and it's ever changing. So I use a lot of the same concepts that I did for film deposition that I did in the 1990s, but I'm using them on new materials. So I'm never bored. I'm kind of doing the same thing, so I can build on what I already know, but I'm doing it with new materials, and there's always new challenges, and it's a lot of fun. So that's why I think STEM careers are fun, because if you think about your phones and ways we used to listen to music and computers and everything, it's way different, and it's going to continue being that way. You're never going to get bored in a STEM career. So key takeaways, things I want you to think about is, when you're selecting a career path, explore as many careers as possible. Listen to as many of these talks as you can to find out what they're like. You may never find a job exactly like mine, but you have an idea about what might be out there that's similar. Don't worry if you don't know what you're going to do. It will work out. I had no idea what Micron Technology was, and I have found that it is an amazing job, and I absolutely love it, and I've been here ever since I got hired on. Haven't wanted to change because it's so exciting. It will work out. Number 2, take time to find your path. So that 1 year that I took off was that time. And also to find out who you are, because I think when you find out who you are, you'll be able to figure out what excites you and what would make you happy in a career. Keep an open mind. I was really afraid that I was going to be alone in a lab. I don't know, I just had this idea that that's what it was going to be. And I finally decided to have an open mind. I took the job at Micron, and it was nothing like I expected it to be. It was much more exciting, and it's good to keep an open mind and not count yourself out of an opportunity. 4th, consider a STEM field, because they're exciting and they're always evolving into a really exciting career. And then finally, 5, do what you love. Find something that you're passionate about and try and figure out how to get that done, how to be a part of that. I'm a proponent of the STEM careers, but I have 3 daughters of my own. One's 21 and she's at college. Well, she's at home now, but at college online, studying biochemistry. I have a second daughter who's also in college. She's studying marketing. And I have a third daughter that's in high school, and I think she's going to go into some kind of, I don't know, personal training or something like that. They're all finding something that they want to do. STEM careers are great because if you have things that you love to do that may not be financially good in terms of supporting yourself, like suppose you like skiing, but maybe you might not be able to make a career out of skiing, then maybe you can do something like have a STEM career and then have the money and opportunity to do that on the side whenever you get a chance. I think I'll also share the next slide. This is one that I have is just sort of a backup slide. And one of the reasons that I like chemistry is that it's a great pathway to many different fields. This was a list that I put together a while ago where if you go into chemistry as a bachelor's degree, it can really be expanded to a lot of different areas. And I highlighted some, bolded some that I was interested in, either that we have at Micron, like analytical chemistry or environmental chemistry, chemical engineering, of course, and then some other ones that I think are great: space exploration, teaching. So important to have good teachers in the sciences. It's just kind of a list to let you think about chemistry as not the end all, but basically a stepping stone into a number of different areas. So just something for you to think about if you're looking into chemistry and say, oh, I don't know that I want to be a chemist exactly in the lab mixing chemicals. There are a lot of things that you can do with chemistry that will take you into a lot of different fields.
Well, with that, Brenda, thank you so much. And do you want to go to the next slide just to remind folks?
Yeah.
So next week, there actually will be another Micron speaker, and she has a very interesting career that includes toilet paper, which we thought was kind of relevant to today's environment. So please chime in again, and we are so pleased that you all joined us, and thank you again, Brenda.
Thanks for doing the polls, everyone. Thanks for being here. We really appreciate it, and have a good time.
All right. Goodbye, everyone. I'm going to end the meeting, and have a great rest of your Tuesday.